Hello, everyone. Thanks for joining, and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our session today will cover OCI Zero Trust Packet Routing, the solutions and services that are available today, what's planned next, some advantages customers have, and how easy it is to get started. I'd like to introduce Radu and Mohammed as our main presenters. And now I'll hand it over to Mohammed to begin today's session.
Hello, everyone. My name is Mohammed Halim. I'm a principal cloud architect with the North America cloud engineering team, focusing on security and cloud native. And I have with me today my colleague Radu Nistor, who's a principal cloud architect as well with the same team, North America Cloud Engineering, and he focuses on all things networking. Today, we will be covering an interesting topic, Zipper, or zero trust packet routing. I mean, it's a new approach to network security that enables enterprises to basically focus on securing their networks via policies, and these policies can span across multiple networks. So the first section of this presentation, I'll be introducing Zipper to you. And then we will follow that with a quick guide to how to set up Zipper on OCI, followed by a couple of very detailed example scenarios that we will be going through to basically give you some context as to how Zipper works within OCI. And then we will walk you through a very interesting demo that showcases the true power of Zipper when it comes to securing networks, followed by a question and answer session. So, introducing OCI Zipper. Now, typically in network setups, we have two intersecting goals. The first goal is how to basically create a network architecture that promotes a free-flowing communication between all your systems, that implements a resilient architecture and ensures that there is no bottlenecks in your network. So that goal now is focusing on opening up these pathways between your sources and destinations, deciding on what topology this network is going to look like. Is it going to be, hub and spoke? What type, number of spokes? How are we going to basically, where is firewalling going to be situated? How we're going to secure the interconnections between your, on-prem networks and your cloud networks, etc. So it's all about setting up the connectivity. Then overlay on top of that goal, the security goal, where we're now deciding or investigating well certain systems, certain sources and destinations will require specific security requirements. So and these requirements will require us to constrain that communication. So that free-flowing communication that we were focusing on when we were designing the network architecture and focusing on network goals, augmented now with security goals, we have to focus now on how we constrain that communication. And that's basically where the firewalls, where the security controls, native controls come into the picture. And, the two together basically give us the desired goal or the architecture. But notice that those two goals can be orthogonal, but they need to intersect at the same time. Orthogonal in the sense that there's a trade-off here, that the moment you add new ports and systems, open up new routes, or fix issues, then what will happen is that you'll need to basically revisit your security goals in order to ensure that your security requirements are still adhered to. And those two together, security goals on top of network goals, can lead to a network that is rendered inflexible by these hard and fast security rules on ports and routes. So let's see now how Zipper can dive to this heart of this problem and help us in addressing this challenge. Now, initially, what will happen is that we will have a source and a destination. That's the desired pathway between the source and destination. Traditionally, you will secure that pathway through these type of constructs. we will talk about endpoint security restrictions on the source and on the destination. You will have remote access mechanisms, effectively opening up pathways between your internet and cloud, VPN, Fast Connect, and SD-WAN, and what have you. Cloud security frameworks. So depending on your hyperscaler in OCI, we have cloud native security frameworks that cover things like native firewalls, security lists, NSGs, network security groups. These are virtual firewalls that you can attach at VNIC level. And then you have firewall rules. And if you look at the firewall rules, too many firewall rules can be difficult to manage and maintain. You have to basically manage cloud security frameworks. These cloud security frameworks will require static configuration across multiple resources, and they can be prone to misconfiguration. So let's see now how Zipper comes into the picture. This is my network layer. On top of the network layer, I'm introducing now a logical layer, a zipper layer, which is effectively a policy engine that allows me to declare my intent using ZPL, which is a policy language. And in that policy language, I'm referring to the sources and the destinations. And I'm very simply tagging my source and tagging my destination. And effectively that way, I'm decoupling my intent from the actual underlying implementation in the network layer. I'm no longer focused purely on how do I implement those security controls at the network layer, but I'm focusing now on declaring my intent, source and destination. That ZPL policy statement is human readable and it is independent of network. The Zipper engine basically effectively takes full responsibility for compiling your policies and implementing those policies at the L4 layer inside your network. Now, one thing about Zipper layer, that is very important to point out is its scalability. In the network layer, everything is IP based. So like we talked about in the previous slide, the brittle or the lack of flexibility sometimes when you're focusing on network goals and overlaying those on top of the network architecture or your network goals is that the moment your network starts to change and you're adding those new pathways and new applications, you're introducing new IPs in the mix. Using the typical traditional network layer, you're going to have to basically augment your firewall rules to reference those new IPs. Whereas here, using Zipper, all you need to do is just tag those extra resources. So if those sources are in a node pool of some sort, you can apply the tag at node pool level, and that's it. That tag applies across all nodes in your node pool. So it's very automatic. It's IP. It's not IP dependent anymore. It's basically tag dependent. Now, in terms of management, you'll notice that with Zipper, your cloud admins will be mostly focusing now on managing the Zipper layer. So they'll be looking at the policies, auditing the policies, amending the policies. They'll also be managing those tags, ensuring that the sources are tagged correctly as well as the destinations. All your resources, which are in-scope resources, are properly tagged, and they'll be focusing on this layer. They'll still obviously be controlling and managing constructs and controls in the network layer, but these controls will become simpler, much more coarse-grained, and all your fine-grained logic will be encapsulated in the Zipper layer. So let's see in terms of benefits now. After this, understanding how Zipper basically is layered on top of the network layer, we can basically focus now here and explain the benefits. In terms of improved security, the policies now, we're focusing only on pathways and we're declaring explicitly those pathways. So the Zipper now is an enforcement layer that enforces declarative policies that explicitly declare the intent of the OCI or networking communication between those specific OCI resources. And the enforcement is independent of the network layer. There is an element of reduced burden as well. So simplification of management, because you're restricting access based on security attributes. So your managers will be focusing basically on, tagging those requisite resources, whether they be sources or destinations. And the simplified compliance now, the intent of the network, the pathways now are not necessarily now purely embedded in very difficult, opaque firewall rules, but they're actually become much more declarative and explicit in those policies, and you can easily edit those policies and actually see which resources are in scope for a policy and which resources are impacted, which resources and which pathways are opened up between your resources. So it's much easier to audit, thereby affording a simplified compliance. Now, let's delve a little deeper to see how that separation, how Zipper works, and how we can actually abstract that security layer from the underlying network layer. We start first by focusing on traditionally how we achieve security via network design without Zipper. So typically in a stack like this, you want to achieve that tiering between your load balancer layer, that's the publicly accessible tier, and your business logic in an API tier. You have your Kubernetes cluster, you have your node pools, and what have you. And then you have that data layer here, that's the database subnet. So usually, traditionally, we will segment those tiers physically in separate subnets, and we will open up subnet routing between those subnets, and we will start basically attaching those network security groups and rules. So a network security group is effectively a virtual firewall, and we attach those firewalls to resources, and these firewalls basically control the ingress and egress out of these tiers. So there's a network security group that allows egress from the API subnet into the database subnet. And you have another network security group attached to the load balancer that allows egress from the load balancer only to the business logic or the API layer. So these multiple subnets attempt to build safe areas, and the safe areas, each subnet will require its own configuration, introducing thereby numerous configurations across subnets. And that's just an example. If you have a hub and spoke, you'll have multiple subnets, hub subnets, multiple fast connects, etc. So you could see now that already we're basically managing multiple configurations across the network, and that then can introduce that extra layer of complexity. So let's see how with Zipper we can start to address some of these challenges. Now, that's exactly the same setup, still the same physical separation. The idea here is to showcase how can I overlay Zipper on top of an existing network setup. You could see here now, I'm not so much relying on the network security groups anymore. They're still there, but they're less granular. The actual granularity here is encapsulated in policies. So I'm starting to tag these resources. So in blue, you could see my load balancer layer. I'm tagging it with the load balancer security attributes. I can see my application layer or API or business logic layer. These resources are tagged with an app security attribute. And then in the back end, you can see my data tier here tagged with the DB security attribute. And then in between those tiers, we're allowing traffic from load balancer to API and from API to database. This is encapsulated in the shape of a Zipper policy. So you can see now that the existing network security in terms of routing and some of the less granular network security rules are still enforced at network layer. They're still taking effect, but I'm overlaying on top of that, a Zipper layer that will evaluate the flows after the existing network security contracts have been evaluated. Now let's see a similar, type of setup, but different in the sense that I'm starting from scratch using Zipper. Now I don't need necessarily anymore to rely on the physical segregation or isolation that that accrues from using subnets. I can use one VCN, I can have one subnet here, but look at how I'm judiciously tagging my in-scoped resources. Now, I'm not bothered about compute 2 and app 2. I'm interested in app 1 and this database. And I want to make sure that traffic only flows from app 1 to the database, but I want to block traffic from anywhere else within the network, not just only within this VCN, but within the OCI network. So what I'm doing now here is I'm deciding or establishing a security model, which means that I need to judiciously design a set of attributes that I can leverage and use and attach to my resources in such a way that I'll be able to write meaningful applications that declare my intent. So notice that I'm creating a tag here called application 1. this apps here is part of a namespace, so it's basically a logical grouping of apps, of tags, but focus on the colored tags here. So this is tag app1, and I have a tag, I'm calling it db1. I'm attaching the db1 tag to the database, the app1 tag, I'm attaching it to the compute or to the application resource, and then I'm declaring my intent. What is my intent here? In this network, in network net 1, okay, allow application 1 to connect to database 1. Okay, so that's the intent now has been declared. That's a policy, gets compiled now in the Zipper engine. And once the policy has been deployed and the attributes have been applied, you know, that's it. The policy now takes effect, and Zipper is going to ensure that traffic only flows from app 1 to the database. Anything else that's out of scope, notice that these are the in-scope resources. Anything that's out of scope that doesn't have a tag is definitely beyond the remit of Zipper and is blocked. So this is effectively, you know, it shows you how powerful Zipper can be, and how we can leverage Zipper to basically declaratively implement network security. Now let's have a look at how we can actually enable Zipper in a typical OCI tenancy. So first of all, the first step, you know, is we need to enable Zipper in the tenancy. We need to unlock that Zipper capability in our tenancy. Initially, tenancies by default, you're using and leveraging traditional native security network security constructs like firewalls, NSGs, security lists, etc. And if you so wish and want to basically add that extra capability, you just click a button and enable ZPR, and that basically unlocks Zipper capabilities, and there's no impact on existing workloads. So if you have existing workloads that leverage native networking security constructs, these will still be behaving as per normal. So next step is creating the Zipper namespaces. Now, remember we said that, you know, we need to basically judiciously design our attributes. So you create different sets of attributes, and you need to basically group and manage those attributes together. Automatically, they're part of a default Oracle Zipper namespace. Think of a namespace as a logical container that contains all these attributes, but you can create your custom containers, right? So you can say, okay, these are the, I'm creating here a container or a namespace called applications. And you can create other containers depending, for different projects have their own different containers or different namespaces. And still, that, you know, adding those namespaces still doesn't have any impact on the underlying existing quote unquote traditional workloads that are currently running on OCI. Next step is actually creating those security attributes, and that's a very, very important step, because you have to be very judicious, and you have to basically, that's you're actually building now the security model. So you can see here now those colored tags here. I have a tag called apps, I have a tag called security zone, and a tag called network. You can see now here, this apps tag, I'm going to be using it to label all my application resources. And I'm going to basically be, you know, it has those 3 values. Now, an attribute can be free form, or it can basically be a list of values type of field or attribute. Here, I'm saying Bastion database web. So when I'm flagging my resources, I need to make that decision. Is this a web resource, which means it's a front end? Is this a database resource, which means it's a database tier? Is this a Bastion? That means, you know, it's it's a private it references a private network or a private tier. So yeah, and you can also, you know, declare resources or categorize resources based on security zones. So you can have some public resources, private resources. So all these attributes, you know, that's the security model that will then you will in turn then leverage when you're actually building those policies, like you will see in the next step. In the next step, you're actually now creating those policies. So I'm actually declaring those intent. I'm actually referencing to those different resources, and you only reference a resource using the attached attribute. So an example here would be, using editing the policies. There's different modalities of editing policies. You can use a template builder. You can actually manually type in your policy. But using the policy template builder, you choose a policy use case, and it gives you kind of a couple of examples by way of policy syntax. So if you look at example 1, effectively what it's saying is that in this network, allow the app1 endpoint, that's the resource that you've tagged with this attribute. So you're referencing that attribute in the policy. You're saying that allow that endpoint or resource to connect to the app1 endpoint in your database server namespace, which we use to basically attach or declare database resources. So that's just an example. Now, notice so far, there's still no impact on your existing workloads. So we've created now the policies. Now, once you start applying security attributes in step 5 to resources, that's when you have to be careful, because the moment you apply that security attribute to a resource, that's it. The zipper engine then automatically enforces those policies that reference these attached attributes. Okay, and you can see here now in this screen, I'm listing all the instances in my in a particular compartment within my tenancy, and all I need to do is click on that instance and then just attach the requisite tags. In this case, one of these instances is going to be a client. And then you could see here there's an autonomous database down below as a resource type. I'm attaching, the database attribute or tag to the autonomous database, and a client attribute to the instance tag. And then there's a zipper policy that references both tags, allows traffic from client to database, and that's it. We've opened up now the pathway between those two resources. Notice that I haven't touched any firewalls, no NSGs, I haven't referenced any IPs. All I'm referencing is just only the tags. And that brings us to the next step, is that once you enable or once you attach those attributes to the OCI resources, your zipper now engine is active. Those policies now are compiled and they've taken effect. And if you need to basically ensure that your zipper policies are actually working, in the sense that your declared intent is actually what you had intended in the first place, and that is obviously an iterative process until you basically reach that final basically end state, which you need to focus on. So this is my last slide, and I'll hand over to my colleague Radu, who will then discuss in more detail some example scenarios and walk us through this excellent demo. So over to you, Radu.
Now that we've seen how what Zipper brings to the table, how we can enable it in the Oracle Cloud infrastructure, let's look a little at 2 examples, and we'll see where Zipper shines. The first example, let's start with something small. Let's say we have quite a small deployment, 4 resources, 2 Bastion servers, 2 databases. Now, the Bastion servers are different in scope. The top one in this diagram is dedicated to internal users. And we also have some external or partner users which need to connect to the environment. Now, we have some requirements. Let's say the internal Bastion needs to connect to everything in the private space, and the external Bastion must be allowed to connect only to specific resources. This example talks about 2 databases, but it can be virtually any resource inside the Oracle Cloud. Now, how could we achieve this? Well, we could achieve it only with network restrictions, but we will also see how we can achieve this with a minimal set of network restrictions and Zipper. Let's look at the network restrictions first. Now, when we talk about Zipper, we have to understand something. We're talking about zero trust. That means that only needed flows are allowed, nothing else. So, if your intent is to open the subnets fully between them, that's not zero trust. Zero trust, only the needed flows will be opened, everything else will be denied. Now, with only networking constructs, we have to be very specific on the rules. In the Oracle Cloud, but any other cloud service provider, we have virtual network interface-based firewall rules. We call them network security groups. These are applied to the VNIC of the resource. And again, if we want zero trust, this would have to be very, very specific. No subnet to subnet, or no fully open ports. We want this particular flow to be enabled and nothing else. So you see here the set of rules, not really that many, but each resource has its own set of rules different from the other. Maybe one of the most important thing to notice is that we are hard coding IP addresses in the rules, right? So imagine that you have to maybe redeploy one of the databases or one of the bastion servers. Maybe you cannot use the same IP. You'll have to go into all the other networking restrictions and edit, add the new IP. Now let's see, can we achieve the same zero trust model but with Zipper? With Zipper first, we must understand that the network layer has to allow the traffic. So the first thing, we build the network sub-infrastructure. Now, in this example, I'm showing that we open the network fully. And that's actually interesting because we can achieve zero trust with a fully wide open network. You don't really have to do that. You can be a little more restrictive on the network when you implement Zipper. But for the sake of the argument, let's say we fully open the network. You see, we have security lists which are applied to the subnet, and we have allow everything. We then come on with Zipper, and we, as Muhammad showed, apply Zipper attributes to the resources, and we create Zipper policies. So I try to color code it a little. The internal bastion has the attribute, users internal. The external bastion has the attribute users external. And then the databases are a little different. Both databases have the attribute appdb, but only the database meant for external access has users external. So on top of these Zipper attributes, we are applying Zipper policies. And we see we have 3 Zipper policies. The first Zipper policy will allow internet connectivity to the bastion servers. So that basically says allow everything to connect to those 2 servers with SSH. The blue Zipper policy allows the connectivity from the internal bastion to both databases, and the green Zipper policy allows connectivity from the external bastion to only the external database. And we see with an open network and free Zipper policies, we achieved the same zero trust. Right? But if we do a comparison, I think we have some advantages that are worth mentioning for working with Zipper. The main advantage, nowhere in our configuration are we inputting IPs, right? So because we are not hard coding IPs, that's a great advantage. Why? We all know that cloud deployments are more dynamic than typical data center deployments, right? You can deploy use a resource for a while, delete it, start it again tomorrow, so it doesn't incur costs. Maybe something gets stuck, you quickly need to redeploy the resource. With Zipper, that doesn't change anything, right? You are redeploying the resource, nothing changes in the Zipper configuration. The new resource just has to get the same attribute as the old resource. Now, one other thing is, let's talk about scaling, right? We only have 4 resources here. What about if we had 50 internal databases or web servers or 100? How would that look with, let's say, network security groups, right? Who would have the operational time to go in and input so many IP addresses in all the networking constructs? With Zipper, that scales automatically with no input from you, right? As long as you deploy the new resources with the correct Zipper attributes, nothing changes. The network stays the same. The zipper policies, we are still having free zipper policies. They will be there after you add resources, right? So I think that's a tremendous advantage. Why? Because you're basically working with a dynamic environment and you don't have a lot of operational overhead, right? Which is maybe time is the most important resource, right? So I guess this shows us the power of Zipper, infinite scalability without any addition, right? Let's talk about example two. Now with example two, let's do something different, right? We have a single virtual cloud network. We have multiple subnets inside the virtual cloud network, and those subnets are, let's say, split by tiers, right? We have a load balancer tier, web server tier, middle tier, and database. What are the requirements? Well, we have multiple projects deploying inside the same VCN, inside those subnets. And we want only relevant tier-to-tier communication. So we wouldn't need, for example, the load balancer tier to talk to the database, right? We want the load balancers to only talk to the web servers. And the other important restriction is we do not want cross-project communication, right? So how can we achieve that? Well, in this example, we're doing something different. Instead of widely opening the network and coming with Zipper on top to achieve zero trust, we make Zipper work with the networking restrictions. How? Well, we give the networking constructs, the networking security constructs, part of the job, right? We are saying in the networking constructs, only this subnet can talk to this subnet. So we fully allow communication between the needed subnets, but we do, but not cross subnets, right? So we still restrict cross subnet communication, but inside the subnet, we then give that job to Zipper, right? So on the bottom, if you see the network security groups or security lists, both will work, are restricting the traffic between subnets. So the load balancer is only allowed to talk to the web servers and so on, right? It's the flow is left to right. And then with Zipper, again, with free policies, we group the resources together based on different projects. Now, what would be some real-world examples for this, project-based restrictions? Let's say, you are an ISV, you have an application template, right? You have a template that you want to deploy for multiple clients. And instead of creating VCNs, new VCNs for each client, you have one single VCN and you apply the template for each new client, but with Zipper attributes. That way, each client deployment, even though it shares the network, it will not go, talk outside of that deployment, right? So the blue client will only be able to talk internally, the resources for the blue client, and similarly, the resources for the green client, right? So no cross talk between the deployments, even though they are in the same subnet and the networking would allow that traffic. Or let's say you have an application that's finance based and you're worried about data exfiltration, right? You group that application with Zipper. You put the Zipper tags on all the resources for that particular application, and that's it. The Zipper will block any traffic egressing to the outside of that deployment. And again, we have free Zipper policies. The red one is allowing traffic from the internet. The blue one is saying only resources that are tagged with the blue attribute are allowed to talk to each other. The green one, the same. Now, scalability, again, is very important, right? What if you want to add another 20, 30 clients? You just create a new tag for that client and a new say zipper policy specific to that client. So one client or one project equals one tag and one zipper policy. Now let's do a let's imagine how would we achieve that with networking uh, restrictions, right? 50, 60, 100 resources grouped together with NSGs, right? And do not talk outside. That would be almost impossible to achieve, right? So as long as we do not hard code any IP, we can scale out quite easily. And the configuration, it's very small, right? Free zipper policies that takes seconds to create. Adding a new zipper policy, again, that's very fast. Uh, and yeah, that's the benefits, right? So uh, that's where zipper shines. Now for the demo, we will implement example scenario one, which is this one, right? We have the two bastion servers. We have two databases. I will use autonomous databases with private endpoints. Let's see how hard it is to implement this architecture. As discussed, whenever we want to implement zipper, first we have to fully open the network, right? So zipper comes in, zipper evaluation after the network. So we have to make sure that the network is opened. This is something that I've already pre-created in the environment in the interest of time. We have two subnets. The resources are deployed inside those subnets, and those are the networking constructs which are allowing all the traffic. And before moving on, let's do some tests. I'm connected to the Bastion servers. Let's do some netcat to both databases. On the top is the internal Bastion, which can connect. On the bottom is the external Bastion, which again can connect to both databases. Let's jump to the Oracle Cloud Console. Now, the first thing we need to do, we have to go to that burger menu, identity and security, zero trust, packet routing. That's the menu. Here, you saw that on Muhammad's presentation. You have to enable zipper. Now, if you already enabled zipper, that's a one-time action per tenancy. If that's grayed out, that means that it was already enabled. If it's pressable, then you have to enable zipper. If you remember from the presentation, step 2 is we have to create security attributes, and those are linked to the compartment. In your root compartment, there will be the default namespace, which is Oracle Zipper, but you can create the namespace inside your compartment. Let's give it a name. You can, give it any name that you want. Let's go with demo zipper. And after we create the namespace, which again, it's a logical container for attributes, we have to create the security attributes. Now, there are 3 security attributes. Let's start with the application, and we give it a list of values. So we have 2 applications, the bastions and the databases. The next security attribute will be the users, which we've discussed. We have 2 types of users. One, users that are internal, and users that are external to your company. And after we create this attribute, the last attribute that we need to create is the network, because everything is linked to the network, right? So let's give it a name for the network, zipper demo. Now that we have security attributes, if you remember, the next step is creating policies. Let's go ahead and see how that looks like in the portal. We have to give it a name. We have to give it a description, and we click add policy statements. And here we have multiple options. We can use the template. We can use a builder, a wizard, where we select various attributes and the values. or we can create manually, and paste them here. I've done that. I've created the zipper policies. Here are the policies. Those are the ones that were previously shown. Again, free policies allow internet to the environment for SSH, allow the internal bastion to talk to the databases, both databases, and allow the external database to only talk to external endpoints, which will be the external database. We create the policies, and then while this creates, we need to go to the protected resources. Now, there are two ways of assigning zipper attributes to resources. We have this menu here. We click it. We can filter by the compartment where we have our resources, so it's easy to find them. We select whatever resource we want to apply the attributes to. We place next, and here we would select whatever attribute we want to apply to those resources. However, we can also go directly on the resource and we can apply it there. Let's see that how it's done, right? Every resource on the Oracle Cloud now has a tab called security. Let's start with the virtual cloud network. You see there is a tag there, a tab. It's called security, and there we can add security attributes. Now the network only allows for only one security attribute, which we've just created, and the other resources allow for up to 3 security attributes. Let's go to the Bastion servers. We have the external, we have the internal. The Bastion server has its own security tab. We go to add it. Now this is the Bastion, so we have to say, to apply the correct tag, and it is an external Bastion, right? So users external. Let's also go to the internal Bastion and apply the correct tags. So this again, it's an application Bastion, and it's an internal. It's dedicated to the internal users. Now that both Bastions have the correct attributes, let's go to the databases. As I said, autonomous databases with private endpoints. The external database has its own security tab. Let's give it the correct attribute. So this one is a database. And of course, it's an internal, this is the external database. Let's also do the same for the internal database. Now, if you remember, the internal database doesn't have users tag, only the database or the application tag. So it does take a few seconds for the attribute to apply. Once it applied, let's check if connectivity is still there. Right. So this is what we achieved. Exactly what we see here was created in the Oracle Cloud portal. Let's try some netcats. Right. So on top we have the internal Bastion, and we see that it's still able to connect to both databases. And on the bottom, we have the external Bastion. Now .11, that's the external database, and we see that it can still connect. But if we try the internal database, it can no longer connect. So that's pretty much how Zipper works. Let's talk about highlights. We saw that it simplifies the network configuration. And how does it do that? Well, you're basically removing or moving the fine-grained controls to the zipper layer. So you're making your network a little less convoluted related to rules, right? Instead of going into multiple places and creating firewall rules, either on the virtual network interface of the resource or in, if you have a centralized appliance, Now we give this power to Zipper, and because we do this, it reduces the complexity, right? Instead of having multiple places where you need to create a new network security rule, you have a single place, which also ties into the centralized management highlight. And this place, you have human readable policies, which are much easier to understand compared to looking at network firewall rules. And we also discussed scalability, right? Uh, Networking, the more you want to be secure, the more networking restrictions you apply, the harder it is to scale, right? You have to create a lot of rules, edit, something changes, go into multiple places and edit. That gives a lot of operational overhead. And Zipper simplifies all of that. You have a single place. Again, it's in a single place where you see all the policies, and it simplifies your networking. Let's talk a little about resources. There is a live lab, and you see the link here. What's a live lab? It's something that it gives you a step-by-step guide on how to implement this inside your tenancy. We have blogs, and of course, there are the official product pages. And with this, I'd like to transition back to Stan. Stan?
All right. Thank you, Radu and Mohammed, for an awesome session. We really appreciate your time and help, and I hope this was a good learning experience for everyone. Right here, we have a few resources if you do want to learn more about Oracle Cloud through either Oracle University and cloud training. And we also have some hands-on experience you can apply with Oracle Live Labs. If you enjoyed this session and would like us to conduct personalized training sessions for your organization, do email us at personal training emails, and we'll reach out to you. If you want us to conduct just a hands-on lab, we have our newly designed Quick Shop Live Labs program for a more expedited hands-on learning experience for specific cloud topics. Under the Code Innovate program, we co-develop a solution based on your own use case. Remember that personal training is an investment we make in our customers to help them grow and develop their OCI skills at no extra cost to them. Our next session will be on June 16th. In this session, you will be introduced to the fundamentals on network firewall on Oracle Cloud Infrastructure and how to get started with best practices. With that, thanks for joining today's session and have a wonderful day.